Look, forget everything you thought you knew about the future of technology. While the whole world has been looking up, totally obsessed with the stars and the AI space race, this massive silent revolution has been brewing deep into subatomic shadows. For decades, the absolute greatest minds in Silicon Valley have been desperately chasing a ghost, a machine so unimaginably powerful it could crack any security code or design miraculous life-saving drugs in literally mere seconds. But for all the billions and billions of dollars poured into this pursuit, they hit a massive wall. I want you to really think about that for a second. What happens when the ultimate computational machine hits an unbreakable physical wall? It's a fatal flaw, a limitation that legitimately threatened to turn the entire quantum computing dream into nothing more than a collection of billion-dollar paperweights. Right, let's dive into this. The experts call this the data reading bottleneck. Imagine you've got a Ferrari engine. That's your insanely fast quantum processor. But for some reason, you're forced to fuel it through a tiny little coffee straw. That's exactly how quantum computers used to work. They could process data at the speed of light, sure, but they had to load that classical data sequentially, literally one bit at a time. It was a total mismatch that completely throttled their massive power and basically halted progress on a global scale. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. China unveils world's first super-fast quantum memory, paving way for practical computing. Advance establishes core element required for general-purpose quantum computing that can read massive amounts of data. With that said, let's go straight to the intro. The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. One like, one subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much. Moving right along to Section 2, the QRAM Breakthrough Mission, Zhejiang University's experimental leap. Well, for years, the scientific community struggled with this silent killer of quantum speed. But then, a powerhouse team over at Zhejiang University completely shattered that silence with an experimental leap. The solution they built is called QRAM, or Quantum Random Access Memory. Basically, think of it as a computational translator. It takes our massive real-world classical datasets, the binary zeros and ones that make up our current digital world, and translates them into coherent quantum superpositions. The Zhejiang University team actually built the world's first experimental bucket brigade QRAM on a physical superconducting chip. They finally removed that tiny coffee straw and replaced it with a massive pipeline, allowing processors to query multiple memory locations simultaneously, completely in parallel. Now, what makes this leap so profound is the sheer efficiency they pulled off. They managed a 30% reduction in circuit depth. They did this through what the researchers call hardware-efficient gate decomposition. Actually, scratch the jargon for a second. In plain English, they optimized the physical micropathways on the chip so brilliantly that it made a 4-bit and an 8-bit QRAM prototype genuinely practical on current hardware. By shrinking the physical distance the quantum information has to travel, they stop the data from decaying before the calculation could even finish. It's a real game changer. To understand how they got there, we really have to look at the underlying industrial strategy. According to recent market analysis from global quantum intelligence reports, as of 2024, China already commanded a massive 25% share of the global quantum market. That represents a $2 billion stake. And this stems directly from China's 15th five-year plan, which explicitly designated quantum tech as a critical future industry. What these source documents reveal is a highly centralized strategy, systematically building an entirely self-reliant quantum ecosystem right from the ground up, totally isolating it from global supply chain disruptions. And this strategy is definitely yielding dominance across multiple types of hardware. The research highlights a staggering number: 3,050. That is the number of photons manipulated and detected by a photonic beast known as Jiuzhang 4.0, developed at the University of Science and Technology of China. To put the gravity of that into perspective, this system performed a complex mathematical calculation in exactly 25 microseconds. If you gave that exact same calculation to the world's absolute most powerful classical supercomputer today, it would take billions of years to solve. Literally billions. Which brings us to Section 3, teleportation and acoustic tech, bending the laws of physics. So how exactly does this translate into tech that frankly sounds like it belongs on Star Trek? Well, the biggest challenge is scaling these systems up without slowing them down. Enter quantum teleportation. When you build bigger QRAM networks, you hit something called the swap bottleneck, where moving data between layers causes exponential delays. But by using teleportation, they can bypass those physical gates entirely. They move data instantly between router layers, maintaining what physicists call logarithmic time complexity. Long story short, no matter how vast the memory architecture gets, teleportation ensures the super-fast memory stays lightning fast. But wait, the innovations totally don't stop with teleportation. Researchers are also exploring something entirely different: acoustic QRAM. Instead of using light or electrical signals, this architecture routes photons, which are individual discrete particles of sound. Because sound travels so much slower than light, its wavelengths are drastically shorter. This submicron wavelength means the physical hardware required for the memory can be infinitely more compact, fitting unprecedented computational power onto a shockingly small surface area. To actually make this compact network function, they use transmons. These are specialized superconducting qubits acting as active routing nodes, essentially tiny, highly resistant switches. They interact with the signals to literally carve physical paths for the data-carrying photons to follow, all while actively avoiding the interference known as frequency crowding. It is this intricate subatomic ballet coordinated perfectly to prevent any data loss. Alright, Section 4, superconducting versus acoustic, the hardware showdown. So, comparing these two leading technologies based on data from the Zhejiang and hybrid QRAM research papers, we can see exactly where things stand. On one side, superconducting QRAM uses microwave photons and is somewhat vulnerable to qubit crosstalk. But as Zhang University proved, it is already an experimental reality with functioning 4 and 8-bit prototypes. On the flip side, acoustic QRAM uses phonons. Its footprint is highly compact, which brilliantly addresses those massive scaling issues we talked about. However, it currently remains a novel theoretical framework, still in active early-stage development. Moving to Section 5, next steps for humanity and the real-world impact, let's pivot from the lab to your everyday life, because cracking this QRAM bottleneck absolutely opens the floodgates for 3 huge applications. Step 1. Medicine. Researchers won't just be testing drugs anymore. They will scan chemical databases containing hundreds of millions of molecules in mere seconds, potentially finding targeted cures for centuries-old diseases before a single physical lab coat is even put on. Step 2. Finance. Global fraud detection will shift to analyzing vast worldwide transaction records simultaneously in absolute real time, completely eliminating network vulnerabilities. And Step 3, artificial intelligence. Quantum AI will act as the hyper-advanced brain of the future, processing massive, complex datasets at speeds that make our current top-tier models look like, well, children's toys. Wrapping up with Section 6, the quantum outro, the new superpower, we are literally watching a profound geopolitical shift happen as the landscape of computing is entirely redrawn. The source documents summarize this breakthrough with a very pointed assessment, calling it the final piece of the puzzle that establishes China as the primary architect of the future. The neutral narrative presented across this research is pretty clear. While much of the world is still actively trying to figure out the theoretical questions of data loading, China has already systematically built a machine that provides the answers. So I've got to ask you, what do you think is the most exciting application for this new quantum memory? Will it be the unprecedented leap in AI, the miraculous cures in medicine, or just something completely unknown that we haven't even conceived of yet? Drop your ideas in the comments below. We read them all, and we use your suggestions to decide our next deep dive. If you enjoyed this explainer, make sure to hit that like button and subscribe so you never miss out on the tech that's literally rewriting our history. Thanks for joining me on this journey into the subatomic shadows. I'll see you in the future. Goodbye.